I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, October 31st.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale pushing up into Alaska, still producing 22-foot seas, but actually doing a little bit better a few days ago, and a new gale developing over the dateline, producing 34-foot seas, aimed pretty well at the islands and eventually at California. Things are still looking pretty good as of this moment. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough, a dip in the jet, just like right there. Now, that's a pretty pinched off trough, but nonetheless, it helps create a counterclockwise flow aloft and down at the ocean's surface, and that's the hallmark of low pressure. And when low pressure is deep enough, it generates winds. When winds are strong enough, they generate seas. When seas are high enough, as they radiate away from the fetch area, they turn into swell. Of course, when swell hits your beach, it turns into surf. So we have a little trough here in the we'll call it the northwestern Gulf of Alaska, being fed by 130-knot winds pushing down into it, trying to keep some circulation going there, but pretty much fading out as we get into Monday. Another patch of wind, not a very big patch, starts developing as it approaches the dateline on Monday with 160-knot winds in it, and that starts carving out yet another trough, supportive of gale development, and that's to continue into the Gulf into Wednesday. Notice that winds also start building yet again in the northwestern Gulf on late Wednesday night to about 170 knots, and feeding this sort of perpetual trough machine that's going on here in the, we'll call it the northern Gulf of Alaska. Then really on Saturday, almost a week from now, a stronger bit of energy, 190-knot wind starts diving into that pre-existing trough, maybe trying to get a little bit of traction, winding up pretty good as we get into Sunday and into almost Sunday night, supportive of gale development. It sort of seems like that's going to be the pattern for a while. Energy pretty much bypassing the northwestern Pacific, focused on the northeastern Pacific from the northwestern Gulf into the central Gulf, feeding, not giving low-pressure systems a lot of area to form, but nonetheless producing wave after wave of small low-pressure systems and gales, pushing into the Gulf and generating swell. All right, let's go take a look down at the surface. So here we are, surface level pressure, surface level winds, remnants of a previous gale fading in the Gulf with no real fetch, 20-knot winds, doing not a whole lot at the moment. But the second in the series is developing over the dateline, which is right there, and about 40 north, which is right there, with 35, 40, a little tiny area, 45-knot winds. Hawaii is right there, probably targeting Hawaii best with fetch pointed in that direction. So we get into Sunday evening, winds fade to 35 knots, still producing some sort of swell, and the same thing as we get into Monday morning and even Monday night. Then the gale starts fading with barely 30-knot winds passing Hawaii, but a good amount of swell energy looks possible for Hawaii. Then the gale is supposed to push towards Northern California here as we get into Wednesday. As we get into Wednesday evening, 40-knot winds and maybe even a little area 45-knot winds right off the coast of Cape Mendocino and Oregon, then pushing into the coast. Another small area of low pressure tries to organize right behind that on Friday in the northern Gulf. Not doing a whole lot. I mean, yes, there's some fetch, but not a whole lot. Then maybe building as we get into near Sunday with 50-knot winds up here off of the British Columbia. We're in between the model, the 12 and the 18Z run of the model, so there's a little bit of discontinuity here, but we're hopeful that maybe that could generate some swell as well. So there's hope, pretty much, at least at the surface, for the coming week. Let's go take a look at the effect of those winds on the ocean surface. All right, so we're going back in time to Thursday. There was a little gale that started developing, actually from tropical origins. Notice there was a tropical system over here as well. This one, same deal, small tropical system. Started getting some traction on Thursday. This is what, 2 days ago? Over the dateline, 28, maybe 29-foot seas building, then pushing over into the Western Gulf, again with 28-foot seas. That was about all she had to produce, but still, swell is in the water. It's currently hitting Hawaii on Sunday afternoon. Some decent-sized sets there, and bound for the U.S. West Coast come Monday afternoon into Tuesday. Local weather could be an issue, though, associated with the front associated with this low. But then, the next gale in the system, right behind that, right in the same position of tropical origin, hang on, and it started building Sunday morning, pushing over the dateline, again with like 28, 29-foot seas, then pushing north of Hawaii. Hawaii's right there as we get into Monday with 26-foot seas fading to 23 feet, and then pushing off east from there, potentially winding up off California as we get into Thursday with a little tiny area there of, what is that, 29.7-foot seas. That's the highest sea height over this whole domain. And winds 47.7 knots at the same location, so right there. So maybe a little burst of local swell as we get into Friday for California and Oregon. And then moving out beyond that, other low pressure tries to organize in the Gulf, but really just can't quite get it together. Yeah, the jet's there. Yeah, things are happening. But it's not till we get into Saturday, Sunday, that new low supposedly starts building off British Columbia with, we'll say, roughly 32-foot seas aimed somewhat south. The low is pushing north. It's really close to the coast, barely in the swell window. So maybe some swell will result from that. It's way too early to tell. A week out on the models. Never trust it. Never more than about 3 or 4 days. So, but we'll keep our eyes on it nonetheless. Sometimes the model surprises us. Now, on top of that, the southern hemi has been producing some small swell. We've pretty much ignored it because of the quantity and the amount of swell coming out of the north, and mainly for central North California. If there's any kind of northwest swell, the southern hemi swell just disappears. I mean, one set every 20 minutes versus sets every 5 to 10 minutes, and of double or triple the size. Though Southern California has had little bits of southern hemi swell this entire week. Another gale forecast developing under New Zealand as we get into Monday with a small area, we'll say like 33-foot seas, and lifting a little bit northeast as we get into Tuesday, fading out. So maybe that's opportunity for another one of these background small swells radiating up into California, maybe 8 or 9 days out. And then another even smaller one on Thursday. Certainly late season swell since we're in, we'll be in November before the swell arrives. Anyway, that gale starts fading out. And on Friday, things pretty much quiet down for real and probably for good after that. Let us take a quick look at local weather. We're not looking for wind swells so much as we're looking for south winds and exposed breaks, which isn't a good thing in California, or some sort of south or even north west wind scenario for Hawaii. As we get into Sunday, you can see a front approaching the northern California coast. South winds building along Cape Mendocino down into northern California as we get into Monday morning. So that's a front more than likely, and that would likely be a problem at any south exposed break in Northern California. The next low, notice how close it is to Hawaii. That's good for producing swell radiating into the islands. We looked at that before, but it doesn't look to have, well, you can see a little bit of northwest winds there, but not like a major northwest wind event. And quickly behind it, winds starting to clock around. California protected for the moment on Tuesday into Wednesday by a little bubble of high pressure, but as we get into Thursday, you can see another front pushing into the north coast. But the question is, how far south do these fronts make it? And it looks like the Golden Gate, for the most part, is, affected, but not really a whole lot. North winds for a little bit as we get into Friday, and trades picking up for the Hawaiian Islands as we get later in the week. And then as we get into next weekend, winds backing off, broad area low pressure setting up in the Gulf of Alaska. Trades continue for Hawaii. We get into Sunday. Here we go. Last little frame here before everything switches over. And then pretty much the same thing. Notice the jump here. Again, the new model still trying to get itself organized here, and pretty much no change after that. South winds, not so much of an issue. So precipitation in California, Northern California, we're in the San Francisco Bay Area. We got, on average, about 4 inches of rain out of that last storm. And the one before that, we got 1 inch. So already, and we're not even into November, there's 5 inches in the rain gauge, which is a pretty good early season setup. Grass is starting to grow where everything was dead. Certainly the fire danger is not an issue. In terms of how much water actually made it into the reservoirs, not a whole lot. I mean, most of it got absorbed by the ground. That said, I did just a casual survey at levels at a bunch of reservoirs, and they're at about, somewhere 40-45% of normal. We need a lot more rain to get us back to the 80 or 90% where things would be a lot more comfortable. So let's go take a look. Is rainfall on the way, or is there snow on the way? All right, so as we get into Sunday night, rainfall, first front approaching Cape Mendocino, rain make it down into the Bay Area by Monday morning, and even down to maybe the south end of Monterey, or maybe Big Sur, something like that, but not a lot of rain. It looks like rain also for the Sierra. Another one approaching as we get into Wednesday night, Thursday morning, front also down to, where is that? Oh, down to about maybe Morro Bay, and looks like some snow for the mountains. Not a lot, but a little bit Thursday night. And then another front trying to organize, but there's this brick wall that makes it pretty difficult for it to seem to get south of the Oregon, Northern California border. And that's about it. So we'll have to see further out what happens. But for right now, a little bit of rain, making it down into barely central California, and not a whole lot of snow, it looks like, for the mountains. Snow forecast dashboard. This is for Olympic Valley. Yes, we'll change that politically incorrect name at some point here, but we're not there quite yet. Maybe a couple inches from the November 4th upcoming rain event, snow event, but not much. The past big storm, which we thought would get 50 or 60 inches, well, in reality, it was about 33 up high. A lot of that attributed to much warmer than normal temperatures. The colder the air is, the more snow you can get out of a lot less water. There's certainly enough water, but the temperature did not switch over to freezing till much later than what the models were thinking, resulting in less snow, and the snow that was there was extremely heavy. But hey, snowfall, skiable snow. I think Mammoth is open, Olympic Valley's open. For them to be open at before Halloween is, I think I heard that's maybe only the 3rd or 4th time in 75 years of operation. So that's all good. We'll take it. Water any way we can get it, and in any form we can get it, is a good thing. Freezing levels, this is the bottom of Olympic Valley. This is the top of Olympic Valley, 9,000 feet versus about 6,200 feet. The white line is where your hard freeze, 32 degrees. This is sort of the slush line. So dipping into the hard freeze mid-mountain maybe on tomorrow. Another dip on the 4th, 5th, where we know there will be some real precipitation. But other than that, freezing level's still pretty high. Not to be too depressed. It's very early in the year, so no one would expect that the freezing level would be down low and would be into a major snowfall event. So, I mean, what we had was really just a stroke of luck. It's good. We'll take it any way we can get it. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation? Of course, either El Nino or La Nina. Well, you know where we're going with that. As usual, we'll start by looking for signs of the active phase of the MJO, the Madden Julian Oscillation. It's this periodic weather oscillation that rotates around the planet on the equator, moving from west to east. The active side is on one side of the planet, the active phase is on one side of the planet, the inactive phase on the other side of the planet. They rotate around the planet. When the active phase moves over the Pacific, and it takes about 6 weeks to move from the West Pacific to the East Pacific, what the active phase effectively is a low pressure system. It pumps energy and moisture up into the upper atmosphere. That feeds the jet stream. When the jet stream has more energy, it produces more wind. When the jet stream has more wind, it produces troughs, which produce storms, which we talked about earlier in the presentation. The other thing the active phase of the MJO does when over the Pacific is it changes the direction of trade winds underneath where the active phase is. So typically trades on the equator are from east to west. But if the active phase is strong enough, it can dampen the trades or actually reverse them and make them blow from west to east. And that, in turn, when the active phase is over the West Pacific, we call that the Kelvin wave generation area, those westerly winds or westerly anomalies can take warm water that's normally there, start pushing it east. If you have successive active phases of the MJO and they're strong enough, it takes a large volume of warm water, starts pushing that underneath the equator the whole way across the Pacific and into Ecuador, and that's how you can kick off El Nino. All right, so let's take a look here. Data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. Now you look at this chart and there's hardly any color on it at all, and that's because we think that either the sensors or the computer or something is not working, and surface data, at least surface water temperature data, is no longer available. I mean, it's been steadily shrinking. Some of you have written to us about this and mentioned it. We go, yeah, the sensors are down. It's a big deal to take ships, get them out there, fix these buoys, because they're 2,000 miles away from anything in exceedingly deep water. So I don't think NOAA and the international cooperation of other partners that maintain these buoys, they don't get out there and maintain them as much as, of course, we'd like. So, but the interesting part is the arrows are still here. The arrows are the wind sensors on the buoys themselves. Those appear to be working just fine. The arrows depict the wind direction out of the east. The longer the arrow, pretty strong. So strong east winds in the East Pacific. Oh yeah, here we go. Equator right here. Okay, this is roughly the East Pacific. This is the West Pacific. The date line right there, 180 west. Equator, 0. That's New Guinea right there. And Hawaii would be up somewhere here. This only goes to 10 north, so it's up here about 22 north. All right. Winds out of the east in the East Pacific over the Central Pacific, and this is 5-day average winds. You can see that right here. Pretty strong over the Central Pacific, and then weaker but still east winds over the Kelvin wave generation area, the West Pacific. But it's not the actual wind speeds, and these are 5-day average winds. It's not like the NOAA buoys near shore that you and I are used to using for surfing or whatever. This is 5-day average. But it's the anomalies, the difference from normal for this time of year. So we go to the East Pacific, there's one arrow just sort of like pointing down nowhere, but in terms of east-west component of the wind, that's what we're interested in. If anything, the anomalies are a little bit out of the west, which is kind of a good thing. That's what you want to see. In the Central Pacific, no real directional data, but over the important Kelvin wave generation area, where, when the active phase is over this area, it can reverse trades. No indication here of a reversal of trades. If anything, they're a little bit stronger out of the east than normal, probably hinting at the inactive phase of the MJO. Next up, the forecast. Zonal wind anomalies. This is the whole planet on one chart, right? Dateline 180 west runs right up the middle. And this is just for winds. I think it's 5 degrees north and south of the equator. All right. The blues are easterly anomalies. One could loosely construe that to be the inactive phase of the MJO. The reds and yellows are westerly anomalies, the active phase of the MJO. Now, 180 west, so here's the dateline. The Kelvin wave generation area starts at 170 west and goes the whole way to as far west in the Pacific as you can get, so about 135 east. So right in here, but you can go the whole way up the chart. What you see is east anomalies have just been prevalent the entire month of October, and they were actually prevalent even before that. I think 90% of September was all easterly anomalies. So this looks like a long-running inactive phase of the MJO, but what it really is hinting at is La Nina, because La Nina effectively is a long, non-stop inactive phase of the MJO over the Pacific, where El Nino is the exact opposite of that. It's the active phase just perpetually set up over the Pacific Ocean. And the forecast for the next 7 days, each tick mark here is a day. Kelvin wave generation area, you can pretty much see it. Easterly anomalies, but building stronger as we get into maybe another day or two from now. So, if anything, the inactive phase of the MJO looks like it's in control. Not great for storm production. Going further out. When in doubt, go further out, right? You do that. Everyone does it, right? You look, you don't see what you want to see on the models 3 or 4 days out. You go for a week, and then you go, well, let's go look 2 weeks out. But the problem is, once you're 5 days out on the models, it's all just complete nonsense, not believable. So we try to restrict ourselves for the most part to a week. But on this MJO stuff, the models do a reasonably good job, maybe a month out. All right, so what are we looking at here? OLR, outgoing long wave radiation. Fancy words for sunlight reflectivity off the ocean's surface. All right, it's a forecast. Here's South America, Central America, Hawaii, New Guinea there, the equator right there. Okay, yellows represent lack of cloud cover. Positive anomalies, positive, a lot more sunlight than normal reflecting off the ocean surface. That's high pressure, that's the inactive phase of the MJO. So it looks like, at least per the statistic model, the CA model, weak inactive phase holding for today, 5 days from now, 10 days from now it falling apart, and maybe a weak active phase developing 15 days, 2 weeks from now. But all this is so weak, pretty much just a dead neutral pattern from an MJO perspective. And looking at the GEFS model, a dynamic model, it's saying pretty much the same thing. I mean, we could argue, the models are arguing a little bit over the fine details 15 days out, but effectively no real MJO signal forecast. So that means no major forcing in the atmosphere to feed energy to the jet stream to promote storms. So it's kind of you get whatever you get kind of thing. No big trend indicated. Phase diagrams. These are the same models. This is the statistic. This is the dynamic. But we're looking at the MJO from a strength and absolute position perspective. So the MJO moves from west to east from the Indian Ocean over the maritime continent to the West Pacific, to the East Pacific, under the United States across the Atlantic, over Africa, back to the Indian Ocean. Where the heavy dot is, which is right there, that's where the active phase is, so probably over Africa. The circle is the strength indicator. The further the dot is out here away from the circle, the stronger it is. And this is the active phase. What we want to see, the ideal scenario, is the dot somewhere way up here in the West Pacific. That'd be a strong active phase in the West Pacific. But instead what we see is a exceedingly weak active phase over Africa, landlocked, doing nothing for us. And the forecast, 3 different potential trends for going out 2 weeks, have it all over the maritime continent, like Bali, that area, and exceedingly weak. The dynamic model, not really suggesting anything different. The green is the track, putting it maybe in the West Pacific 2 weeks from now, but again, exceedingly weak. The upper level model, so it too is, now it's suggesting this is potential for precipitation. The yellows, oranges are dry air, which again could be linked to the inactive phase of the MJO. The greens, wet air, suggestive of the active phase. Just eyeballing the chart right off the bat. Oh, and this is a 40-day model. Each panel here is 5 days in length. You just see a lot of yellow and not a lot of green, suggesting dominance of the inactive phase of the MJO. All right, so anyway, today, here we are. Oh, let's get oriented. 0, that's the equator right there. South America right there. Central America right there, Hawaii, just a little speck of it right there. New Guinea there. Kelvin wave generation area. Oh, where's the equator? I mean the date line. It's not here, but it's not depicted, but it's roughly right around here. Kelvin wave generation area, just generally in this area. So what we see is inactive phase over the, we'll call it the Kelvin wave generation area, making its way across and into Central America by November 20th. The active phase, a weak active phase of the MJO, pushing out over into the Kelvin wave generation area on November 10th, making its way across the Pacific and into Central America by the end of November. Okay, so the month of November is probably a spot for storm production because that's when the active phase would be over the Pacific. Then after that, again, the inactive phase developing as we get late into November and pushing its way across the Pacific, and a little bit stronger as we get into mid-December. So not a whole lot of significant forcing in the atmosphere over the Pacific Ocean, according to these charts. We'll look at another model here, the CFS model, going out 1 month, whole planet on one chart, date line runs right up the middle, okay? For the far west Pacific, 135 east, so right about here. And then New Guinea would be, Ecuador would be somewhere over about here. But it's this area that we're interested in. And you can see again, going down, the blues are easterly anomalies, the dominance of the inactive phase of the MJO. Now here is, the solid contour is an active phase of the MJO that supposedly was over the Kelvin wave generation area most of the month of October. It's fading out, moving out of the Kelvin wave generation area, moving from west to east. And the dotted contour here is the inactive phase of the MJO. That's starting to make its way across the Pacific, starting about today or tomorrow, and should be across the Pacific and out of the Kelvin wave generation area by November 16th or so. But notice, as it moves over the Kelvin wave generation area, a solid, strong batch of easterly anomalies are forecast. So this is a little bit different than some of those other models we were looking at. A little bit of disparity here, but the CFS model definitely suggesting a strong inactive phase. But then also notice a strong active phase building over the maritime continent as we get into mid-November, starting to make its way into the far west Pacific about around the Thanksgiving time frame. And then finally, if you think a 1 month model goes out too far in the future, we have a 3 month model. Same CFS model, but it's kind of fun to watch. We'll talk a little bit more about this. Okay, previous performances down at the bottom. The forecast is up top. Dateline, again, whole planet on one chart running right up through the middle. This is what's happened in the past. Today, here's where we're at. Kelvin wave generation area from about here, 135 east, to about 170 west. So right in here is the area we're focused, going the whole way up the chart. Inactive phase of the MJO looks to be forecast as we get into November, followed by the yellows are westerly anomalies, taking over the Kelvin wave generation area, theoretically into December even, but then starting to fade out. Let's add the actual MJO contour. Here we go. Active phase of the MJO, the solid contour, just about out of the Kelvin wave generation area now. The inactive phase starting to build, pretty solid. Forecast going into, we'll say, November 20th. The active phase starts about mid-November, takes over the Kelvin wave generation area. Now, previous runs of this model had this active phase much larger in coverage, going the whole way up into, December. Now it's just a thin little slice, still with decent winds, but we're still almost a month out from that happening. We'll see if it whittles away even more. Followed by an inactive phase of the MJO, but westerly anomalies trying to hang on. But then as we get into January, it looks like easterly anomalies, certainly over the East Pacific, perhaps retrograding and building into the Kelvin wave generation area. Let's overlay the low-pass filter. This is high and low pressure biases over the planet. And this is what drives not the MJO, but El Nino and La Nina. So last July, well, actually that's this year, the solid contour is a low pressure bias. Just think of it as an area of low pressure, but it's like semi-permanent at 120 west. So this would be the far, far west Pacific. And with high pressure locked at 120 west, that would be south of California. This explains the extreme lack of water last winter. Now notice the difference in position as we move into this coming winter. The high pressure bias moves smack right over the date line with 2 contours. Last year's, I think it was like 4 contours. So weaker, but right over the date line. And forecast now to hold the whole way into January. It did look like it was going to die out with the low pressure bias over the maritime continent. But notice this, trying to weasel its way into the far west Pacific, getting about we actually sat and figured out about 150 east, so about halfway into the Kelvin wave generation area come January. So what this suggests is that, and also notice the displacement of the high pressure bias more out over the middle of the ocean, that we think that will give a better opportunity, just like the storm we had, was it last week, for systems, high pressure smack right over the date line, but low pressure systems would rotate or move over, over the date line, then down into the Gulf of Alaska. If we get a map up here, in fact, let's do that real quick. So let's try it here. The high pressure bias centered over 180. So what that means is generally high pressure on the equator, so right here, driving the jet stream to the north, and if it's focused here, then the jet stream falls south through the Gulf of Alaska, just like what we see here forecast come Saturday, and setting up low pressure in this area. And that's been the pattern so far this year, and we really have no reason to believe that won't continue to be the pattern as we get at least into the early part of winter. So again, here, high pressure bias forecast for the next 3 months over the date line, much like we have low pressure in the West Pacific. So storms not the West Pacific, over the maritime continent, Indian Ocean, coming out of the Indian Ocean, pretty much driving over Russia and China, getting pushed to the north over the date line, and then California, 120 west, falling into the Gulf of Alaska somewhere in this region, and we expect that to be the pattern ongoing through the rest of the winter. All right, let's go look a little bit long term now. Let's go look down in the ocean. This gives us some more clues about La Nina and what it's doing. So we're looking at data, again from the TAO buoy array, those buoys strung across the equator, but we're looking down into the ocean. These X's are sensors that are on the anchor lines of the buoys, anchored to the bottom of the Pacific Ocean, going the whole way across the equator in 15-degree increments. All right, there is some missing data, of course, and the sensors here at 140 are completely out. But still, the idea is you get the data from the sensors, you run it through a computer with a model, it helps fill in the gaps, and you get a profile of where the warm and cold water in the ocean is. In the far west Pacific, the 28-degree isotherm has actually backtracked. It was at 180. Now it's back to 175 east, meaning warm water receding. The 26-degree isotherm was over at 125. Now it's at 138 west, so it's backtracking too. And you can see all the warm water in the Pacific Ocean, more in the West Pacific, a lot less in the East Pacific. The little bit of warm water there is, very shallow. This is a steeper angle of the thermocline. Okay, but it's not actual temperatures. Again, it's the anomalies, differences from normal for this time of year. Again, in the East Pacific, you can see it here. Cold water, 1, 2, 3, 4, 5 degrees below normal at about 125 west. So on the equator, south of California, very cold indeed. Warm water, 2 degrees is 2 degrees Celsius, by the way. So let's say roughly, 4 degrees Fahrenheit. All balled up in the West Pacific, can't get anywhere. Why is that? Well, if you have stronger than normal trades blowing from east to west here, they take all the warm water, just like here, that would be here, pushes it off to the west, gets balled up there. If you have no active phases of the MJO pushing off the Indian Ocean, bringing westerly winds with them to try to take that warm water, push it off to the east, then it just sits there and goes nowhere. And what you end up with is the more east winds blow, the more upwelling you get, and temperatures start falling below normal. And that's what this is. This isn't absolute temperatures. It's relative to normal for this time of year. Temperatures are way below normal here, of course, driven by La Nina and stronger than normal trades over the Pacific. Another model using the same data and some other data suggests exactly the same thing. Very cold in the east, very warm in the west. Brick wall between the two of them. No active phase is coming to break the log jam. We need trades to collapse so that warm water can start sloshing back to the east. But it doesn't seem like that's going to happen, especially with that high pressure bias building over the date line. sea level anomalies. So this is just, is the ocean higher or lower than normal? You use the Jason 3 satellite, strip out all the waves, the wind waves, the tides, and is the sphere of the ocean a little bit less than normal or a little bit higher than normal? What you see here, these are centimeters, minus 15, minus 20, minus 25 centimeters. Oh, and this is the equator. This is the date line here. There's South and Central America, South America, Central America, Mexico, Hawaii right there, New Guinea right there. Okay, so this is the East Equatorial Pacific, and everything's about the equator. It's literally 10 degrees north and south of the equator from Ecuador the whole way across the Pacific. The West Pacific over here is your Kelvin wave generation area. That's where you get your Kelvin waves. Over here is in the central part of the zone is the El Nino La Nina monitoring zone. And then over here is just, it's a lot of noise. It's hard to tell what's going on off of Ecuador and define any or discern any meaningful trends coming out of that. But seeing 25 centimeter below normal, this means the ocean is below normal. Oh, and why is that? Well, if you have cold water at depth, cold water contracts, right? It'll create a divot on the ocean surface. Over here, you have warmer than normal water at depth, not at the surface, at depth. Warm water expands, creates a bump on the ocean surface. So this just sort of is another way to confirm what we saw in the previous charts. Trades blowing, scooping water out, cold water at depth, creating this hole or this indentation in the ocean, taking whatever warm water is here, just slamming it over here into the West Pacific. And you can literally see, like a horseshoe, the east winds pushing into the West Pacific, and the warmer water trying to flow out around the bulldozer that's pushing into it. This is classic La Nina pattern. Second year in a row, too. This chart tells the whole story, all right? West Pacific here, East Pacific here. Upper ocean heat anomalies. So it's relative temperatures in the upper 300 meters of the, where's my hands? There you go. In the upper 300 meters of the ocean. So it's not the surface, but it sort of gives you an idea of balance of where temperatures are. Last November, the peak of our La Nina, cold waters here at, what is that, about 130 west. And then you see, as we got into March, active phase of the MJO developed, created westerly anomalies, took some of this warm water that was all balled up here because it was just nuking east trades. Warm water piled up here, 1 Kelvin wave. Warm water making it the whole way across the Pacific. Another Kelvin wave. A third Kelvin wave, and then you hit July, the whole machine just broke down, and then the same thing started again. Easterly anomalies started picking up, only this time stronger and the much larger footprint at depth. So really what this means is a larger volume of cool water is at depth and a little bit more eastward displaced, but not much. And we're waiting to see warm waters build up here like they did last winter. It hasn't done that yet. Back in October, we're probably about at the same place we were. So the expectation is warm water will start building, and then somewhere in the early February, March timeframe, typically when you have these big transitions between El Nino and La Nina, that's typically when they're going to happen. We don't know if anything significant is going to happen in February. Probably not, because we've had 2 years of La Nina. That pattern is well entrenched. It has changed the global upper air circulation. And even if something does change at the ocean, it's probably going to take 6 months to 9 months before the atmosphere around the planet responds in kind. All right, so what's going on at the surface? Ocean temperature anomalies, sea surface temperature anomalies, SST anomalies, over the Pacific Basin. This tells a lot. So South America, Chile there, Peru, Ecuador, Central America, Baja, Hawaii, where are you? There you are, right there, okay? And the equator, roughly right there. The colds are cooler than normal temperatures. The yellows, warmer than normal. Real clear signature, cooler than normal water, pretty much filling the South Pacific, though most of the cooler temperatures start right at about California and then work their way out to a point about south of Hawaii. So the balance of the cool water is further to the west than it was last year, and there's this perpetual pocket of slightly warmer water here. It's been in place for all summer and still into the fall. We'll see how long it lasts. But this suggests that the balance of the La Nina cool pool is further to the west than it was last year. And that's good because wherever the cold water is, that's where high pressure gets anchored. So it's anchored more, we'll say, out in here, and that allows, again, that pattern where the jet stream rises over the high pressure where the cool water is, then starts falling down the coast. And it's only the water mainly on the equator. Don't get all concerned about this stuff at 20 or 30 degrees in the north or south of the equator. It's mainly 10 degrees north and south of the equator. So again, we believe this is going to, since the cool water is not like all just mashed up here along the Galapagos, Ecuador, under Mexico, but more out here, that we believe will at least open the door for the potential for rainfall to make it into California this winter. Sea surface temperature trend. All right, so our water's getting cooler or warmer than normal. Again, all we care about is directly on the equator. Generally warming off of Ecuador over the Galapagos out to a point about south of California, then generally cooling again from over that same window, 120 west out to about 160 west, where the cool peak of the cool pool is. And that trend seems to be reinforced, at least for the moment. And then the backed off view. Get out of the weeds. Let's just look. Where is the cool water? Well, clearly you can see the meat of it is right in this area right here. But we cannot be blind to the fact that there's cool water over a giant portion of the Pacific. There's this little bit of warm pool here. We're kind of just hoping that this really is the case. So all the data seems to suggest a westward displaced La Nina this year. Again, allowing at least a better opportunity for moisture into California as we get deeper into winter. Sea surface temperature trend in the Nino 1.2 region. This is the area on the equator right there by Ecuador, the Galapagos, that sort. Temperatures today, 804 thousandths below normal, almost a degree below normal. This is kind of a noisy area, but you still see just if you drew a line through this, the trend would be downward, not upward, suggesting a building La Nina. The official El Nino/La Nina monitoring region, the Nino 3.4 area, temperatures 978 thousandths of a degree below normal. And again, the same deal, the downward trend, not unexpected. Here's where we are, pretty much hovering the past 3 days down in this nearly 1 degree range. It's a half a degree below normal for 5 consecutive 3 months periods. We just generally say 5 months. That's the classification temperature-wise for La Nina. We officially crossed that threshold in, about September 25th or 26th. But all data seems to indicate we're already well into La Nina. All right, so we've talked subsurface. We've talked the MJO thing and sort of what's the balance? Are we more in favor of the active or inactive phase in the Pacific? And clearly it's inactive. We've talked ocean subsurface temperatures, clearly cooler than normal in the East Pacific, indicative of La Nina. We've talked surface temperatures, clearly a cool pool, well entrenched on the equator, looking like a westward displaced La Nina. What's going on in the atmosphere? What's the atmosphere think is happening, okay? If you have cold water on the surface, typically you get less evaporation. Less evaporation leads to the development of high pressure, and of course high pressure does not do well for storm production. It doesn't do well for rainfall. It doesn't do well for a lot of things. All right, so this is the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Tahiti's over the Pacific. Darwin's over more or less the Indian Ocean. When pressure is lower than normal over the Pacific, i.e. Tahiti, the index goes negative. Today, hey, nice, minus 1.48. We'll take it. Any little smidgen of negative, we were down at minus 3 or so a couple days, and a couple of spattered negatives there, but if you go back a month, overwhelmingly, the index has been positive, and strongly so, 28.43 in mid-October, and I think even back the month before that, it was plus 36 or something for one day. So, but this is pretty noisy. Let's do the 30-day average. Sort of takes all the noise out of it. The value today is 7.56 and actually falling. So the high values, or when the trend is higher, that's typically the inactive phase of the MJO. And then as the numbers fall, that is indicative of the active phase moving over the Pacific. So maybe a weak active phase trying to set up. We kind of look back the whole month. We've been positive the whole time. Okay, the 90-day average. Today's value is 7.19. What has it been the past month? Well, pretty much the same, 9.5, but at least it's falling some. So this is your El Nino La Nina indicator. If you're pretty well positive, and this is getting there pretty well positive, then you're in La Nina. If you're pretty well negative, then you're in El Nino. Clearly, we are not in El Nino. We're in La Nina. The question is, how deep into La Nina are we? Here's a 30-day moving SOI graphed out so you can just sort of see. Back 2019, we had negative values. The downward spikes are the active phase of the MJO. When the active phases are dominant compared to the inactive phases, the index goes negative. But then you get into last year, the inactive phases were much more dominant, drove the index up to 20 at one point there, okay? Then this summer we had a bit of a break. We had almost looked back to neutral, but here we go again. We're on this steadily upward rising trend, again, just like last year, suggesting the development of La Nina. We got up to, well, 20 at one point there, but in October we were at about 10, let's say. That's kind of almost where we are right now. Almost looks like a mirror copy of last year. Interesting. Doesn't look like there's any way we're going to get out of La Nina this year. And then finally, the modeled forecast for sea surface temperatures in the Nino 3.4 region, the official El Nino monitoring region. All right, mid-October, these lines are in the middle of the month. So mid-October, confirmed data, temperatures about minus 0.75 a degree below normal. Forecast per the raw data, going down to minus 1.6 degrees below normal, and then quickly rebounding as we get into next summer. But this is a little bit noisy. The PDF corrected, probably a better version, suggesting temperatures only going down to about 1.4 degrees below normal, which is about like what it did last year, I believe. The other thing is, this was down to 1.5 degrees last week, so the model, and the same thing on this one here, it was down like 1.75 or something like that. So the models are sort of softening up a little bit as of late, suggesting, well, maybe not quite as extreme as what the models thought it would be even a couple of weeks ago. All right, so for right now, we have some swell in the water hitting Hawaii, bound for the U.S. West Coast. We have another gale developing out over the dateline, supposedly going to make larger surf for Hawaii. Not huge, but maybe in the 12-foot Hawaiian range for exposed breaks, which wouldn't be bad. And then also making its way towards the U.S. West Coast, smaller in size, but then also potentially wrapping up off the coast and building yet again. So a series of swells in the water, and the expectation is even after these two systems pass, there's going to be more behind that. Nothing huge, all of it pretty local relative to Hawaii or the U.S. West Coast. The focus on California and Oregon, just given the jet stream configuration we talked about. Maybe a little bit of southern hemi swell in the mix for Southern California. In terms of precipitation, nothing huge or solid like what we went through last week, but maybe steady light rain, and it's about normal for this time of year. Snowfall, not a lot of snowfall on the forecast for the next week, but it's still early. Temperatures are pretty warm. If it were cooler up in the Sierra, I think we'd be getting more snowfall, and all that's good, right? Precipitation in any form is what we want. All right, if you enjoyed the video, give us a thumbs up. Also, new look here. higher resolution camera. We're giving it a try. Maybe a little bit dark a little bit, but we're trying to work on that. We'll lighten things up. All it takes is money and equipment on a lot of this stuff. So we're working on that. But if you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. If you don't want to subscribe, that's okay too. The link to the video, the videos are posted every Sunday. Link at the top of the website, stormsurf.com. Go there. Follow along, look at the wave models, the buoys, all that kind of stuff, and then test your knowledge, build your own personal forecast, and test it with the video. And if you disagree with what I have to say here, then please write a comment. Let's talk about it. I learn something from people all the time. There's a lot of smart people in the world, and it's good to keep your eyes open and listen to what people have to say. So anyway, that's it for this week. We will do it again next week, same time, same channel. Thanks for watching.